Hello, everyone. This is Colleen Milton, and on behalf of Univa and 451 Research, I would like to welcome you and say thanks for attending today's webcast titled A Sea of Change, Migrating Workloads and Applications to the Cloud. Leading off the discussion today will be William Fellows, who is founder and research vice president at 451 Research. Following William will be Rob Lalonde, who is vice president and general manager Navops at Univa. Just a few quick housekeeping items before we get started. To ask a question, simply type it in the question box on your screen below. We will answer as many questions as we can during the Q&A session, and we'll respond to all unanswered questions via email after the webcast concludes. This presentation and slides are available for download. And finally, please provide feedback at the end of the webinar. And with that, I'll turn it over to William.
Thank you for that kind introduction. And please do, folks, think of questions to ask myself and Rob as we go along here. So if we can move. Can't seem to move the slides forwards. Hey, Colleen, would you be so good as to move the slides on my behalf?
No problem. One moment, let me move these. All right, here we are. The floor is yours, William.
My apologies for still can't seem to move these forward. I'm not seeing anything. Have you moved them forwards, Colleen?
Yes, I have. I can see them on my side.
I can see it as well. They look good.
Okay. Okay, sorry, folks. Just a few technical difficulties there on my end. Okay, so let me start again. So please do think of questions as we go along. And thanks to the folks at Univa for giving me the opportunity to front end our discussion today around HPC and cloud. So first of all, I just wanted to frame up, I think, where we are with things. So we're a research organization, and what we've noticed, we own and operate a panel of some 90,000 folks for whom IT, enterprise IT is their day job, and we obviously survey them for their intent moving forwards. And about 90% say they're going to be using cloud within a couple of years' time, and we think that that means that there'll be an increased momentum around the use of cloud-only and cloud-native processes and policies over that period. And in a sense, I think this represents the fact that everyone is becoming a service provider, because cloud is really used as a underpinning for digital transformation, and every organization, pretty much on the planet wants to offer digital services to their customers over and above, or in addition and alongside to all their other products. So, in a sense, everyone's becoming a service provider. We've seen this real sort of sea change in attitude towards the use of public cloud, and even in regulated industries and different vertical industries too, where typically they've had to use very sort of specialist high performance equipment. This is really opening up to cloud now as well. The second sort of characteristic of what's going on over the next couple of years is that we think that the IT deployment is going to be moving primarily off-premise, and that there will be a greater amount of spend, therefore, on the buying of cloud services versus the building of clouds and so on. It'll be characterized by the importance of partner ecosystems in all of this. Just a fun fact that 90% of Fortune 100 use partners to access AWS. And as a technology research company, we do market sizing and segmentation, and this market is growing at a clip. We expect the aggregated cloud hosting and managed services market to be about $125 billion in 2018. And the cloud segment is about 20 billion of that. It's growing faster, but as you can infer from that, actually hosting and managed services is still 4 or 5 times bigger than that cloud as a service market. So really I think there's a land grab going on here, really, as companies and enterprises convert to cloud. And I think what we should, the sort of defining characteristic here is that the majority of opportunity is in front of us. And because of that, there's a great amount of disruption, but a great opportunity at the same time for services companies to support the transformation that's going on in the marketplace, because it's no longer only about keeping the lights on, being IT-centric and running the business. Instead, enterprises are looking for trusted partners who can help them extend, grow, and transform their businesses. And the role of cloud here is that it takes organizations to firstly a new technology model which is consumption-based and service-driven, with a retail model discipline, if you like. But secondly, it changes the organization to one which is, rather than driven by top-down and allocated approaches to waterfall and agile styles of development and so on, from a CapEx model to an OpEx model, and indeed from, allows you to develop from only products perhaps to services as well. So for all of these reasons, what's going on at the moment is quite a significant transformation across our industries, and this is supported by this conversion to the cloud. So what about the applications and workloads themselves? What's going on here? So turning to our commentator network, which I referred to previously again, what we're seeing, what this data shows in front of us here, is that over the next couple of years there'll be a shift or a pivot to the majority of execution venues being off-premise. So today the majority of IT execution happens on-premise. That's the red and the orange, which is about 52%. Over the next couple of years, that'll shrink to about 30%, and about 70% of workloads will then be in hosted environments. So that's the first kind of characteristics or dynamic of to support what I said earlier about this sort of sea change. The second piece is to reading those numbers a slightly different way and looking at actually the execution in environments themselves. What we can see is that the conversion to cloud takes place both to public cloud and also to private cloud. So the use of public cloud services increases from where it is today at 17 to about 30%, and private cloud from 28 to 38%. So although cost reduction is still a key factor in driving these sort of workloads to cloud, the agility and sort of technology access and modernization are clearly coming into play here, and this is happening again across all industries, where previously I think we could have thought about some industries being first movers and early adopters. This is happening across the board now. So the other characteristic is really that we're heading down a world which is essentially multi-cloud, and the data here, we've asked our commentators which kind of cloud deployments they're going to be using. So about a third say a single cloud, nearly a third saying multi-cloud, so multiple sort of clouds for used in discrete projects and so on. Then about a quarter using multi-cloud in a way where there's some mobility of data and so on between applications and workloads, and a smaller number in a fully hybrid model, so using separate and discrete logical resources to fulfill a single business function. I think the important thing here is that what we're seeing is that more than 40% of organizations are going to have clouds featuring some kind of migration or interoperability over the next couple of years. And what we've seen is that the public cloud is kind of emerging as a distributed edge for customer engagement and employee productivity apps, and especially organizations with sort of large systems of engagement are moving most quickly towards these environments. Companies are starting to see the benefits of aggregating traffic in data centers that allow them to access more than just one hub, as well as business partners. It allows them to select the most appropriate service for the workload and so on. But I should underscore the fact that for much of the time this will happen quite often by default rather than design. It's a bit like life. Stuff just happens, and especially with clouds, decentralized kind of purchasing, especially around big organizations, it means that there is that these multiple cloud is going to kind of fall into use in any case. So how are these applications and workloads getting onto cloud environments? So when we've asked, what's the primary deployment environment for reason for using cloud, so about 50% is for deploying net new, specifically developed applications using the same kind of let's call them cloud native techniques as the actual clouds themselves are built from. The other 50% divided between the classic kind of lift and shift, which has been an approach, sort of a cloud first approach to move everything to the cloud, and secondly refactoring and modernizing code before you take it into the cloud. And we think that lift and shift at the moment is losing ground to refactor approaches because of the complexity in and the cost associated with doing these lift and shift deployments, whereas companies are looking to mitigate the likely disruptive effect, the complexity and cost by doing whatever they can to be prepared or ready themselves for cloud deployments. So where is the opportunity? So we think that going forwards, infrastructure really is sort of table stakes, and really the opportunity is for delivering value-added services beyond the infrastructure in a ratio of about 30 to 70 in favour of the things that you would add on top. So just to give a sense of what's out there and being used at the moment. So firstly, the vendor environment, and I don't think it comes as any surprise that Amazon and Microsoft is the most popular combination of services, although that doesn't speak to the size of those deployments. And one point of interest from the research, so the revenue that Amazon does in cloud is more than the sum of the revenue of the 245 other cloud IaaS vendors that we cover in the research. So nevertheless, Microsoft and other environments are coming on stream as material, real services. But when we go to the network and say, well, actually, who is your most important IT supplier, it seems that Microsoft is actually now with a credible cloud presence and pedigree is strengthening its enterprise position as the key supplier. Obviously, you can see here that the company which is really accelerating its position very strongly is Amazon, and really let's call them the longer tail plays really have now got to try and prove that they are still relevant over the long term. When it comes to the services themselves, the services beyond the infrastructure which are falling into use, as you can see here, it's interesting to us that those which are going to grow fastest, including the data and analytics, the machine learning, and IoT, and so on, these are activities and functions which are going to require, a tremendous increase in the amount of compute and the amount of infrastructure that they use. So, while infrastructure, supports the value-added services, the increased use of services drives a significant uptick in the, and indeed demand for the basic infrastructure services themselves. We can see that the adoption plans are pretty strong across all of these. So what about high-performance computing and cloud? So, these are two worlds which have been orbiting each other somewhat independently, I would argue, until recently. The belief has been that cloud introduces, with its abstractions and virtualization, a set of speed bump and latency inefficiencies which are unsuitable and indeed uneconomic for the requirements of high-performance computing. But I think we all know that, with the advances in both hardware and software mechanisms now, in other words, they're starting to use a lot of the same, onboard chip capabilities as well as the software constructs around, containers and so on, that indeed HPC is becoming certainly much more mainstream to the public. No longer is it only about 3D modeling, simulation, Monte Carlo, etc. You see it on a day-to-day basis when your bank or financial services company calls you to ask if you actually made a transaction, and that happens in real time. In personalized medicine, where you can now decode your own DNA, and Fitbits and other personal monitoring devices have really changed the way we think about health, and indeed, the associated insurance and other services. In smart cities, it's not only traffic and transport and so on, but utility consumption and planning for those things is changing pretty dramatically as well. Autonomous vehicles, as we know, not only need those on the ground need an enormous amount of data, but this is going to happen in the air as well. 3D printing and so on is really shaking up manufacturing, and HPC is really driving that, together with things like augmented reality, both in gaming and in industrial use as well. So there are some very obvious and clear convergence points already. So and why is that? So the rise in use of containers and the ability for HPC companies to be able to take advantage of containers really now is growing in momentum, and indeed, I suspect, it'll be around in this area where applications and workloads are really going to be sort of become blurred between cloud and HPC, especially when the kind of traditional HPC apps get made over for cloud native, and indeed net new cloud native applications are written specifically for HPC environments, and that may be for the quote-unquote big compute offerings from hyperscalers, as well as for the HPC technical engines themselves. Enterprises are going to have, you know, a wider set of choices now where they can go and do this. But, you know, one of the things that will need to be decided is, you know, who can be a trusted advisor in those high performance and technical environments, and, you know, do the, you know, WYSIWYG hyperscale vendors offer enough in terms of enterprise relationships to do that. So we think the rise of all of the things which demand big processing of large data, whether it's, you know, machine learning or AI or anything else, again, that'll really drive requirement for HPC offerings. And I think I've already touched on how the range of offerings and therefore the economics is being driven so that it becomes more affordable now for organizations to undertake the kind of things that were unthinkable when they would have to go and actually purchase their own, you know, capex IT equipment to do that. Instead, you know, they can just rent it. So HPC and cloud, then, how are these really coming together? It's a real, you know, interesting part of the industry conversation now, and, you know, not a day goes past where there's some new offering which provides a really high performance function or capability, whether it's a new chip or service offering, or a new software construct. However, I think it's still true that the largest scale jobs can't be replicated in the cloud. And if HPC is core to a business, then, you know, those running can match or exceed the cloud in performance and even costs, you know, through expert optimization. And I don't think that's going to change anytime soon, although for the smaller scale environments where it's maybe tens or hundreds of nodes, when an organization doesn't have HPC as a core skill set, then cloud becomes attractive because of all of the things that we've talked about, the flexibility and ease of use and so on and so forth. So cloud and HPC, well, if we take a look, for example, at the top 500 supercomputing list, we can see that below the sort of top 100, a growing percentage of the list they're really hyperscale vendors rather than real sort of HPC companies. So, you know, Google clusters and so on, if Google ran the right benchmarks on its like 50,000 node systems and the right workloads to qualify, it could probably crowd out many of the sort of existing HPC systems in the entire top 500. The difference, you know, largely comes down to the differences in the interconnect technology used and the low latency sort of InfiniBand, proprietary links, and, you know, all the low latency requirements of traditional HPC. And that's really, you know, from a technical point, what separates those two worlds still. Nevertheless, it is becoming heterogeneous. You know, there's Intel that's going to be challenged by ARM, and AMD and IBM with, you know, Thunder X2 and EPYC and Power and so on, which are, you know, becoming interesting options and have integration sort of capabilities, you know, with non-Intel systems. And a processor-independent software ecosystem is also sort of gradually coming on stream as well, based upon Linux and so on. So cloud providers themselves are becoming HPC enabled as they get demand for AI, machine learning, analytics, and so on. You know, specific workload requirements, whether it's graphics or intelligent search and stream processing, you know, really has led to, you know, a Cambrian explosion, if you like, in the development around new infrastructure types powered by GPUs, FPGAs, and specialist AI processors like, you know, Google's TPU. And these we think are going to extend to the edge, where the edge and cloud have got to cooperate, such as autonomous vehicles. The HPC world, which instigated, of course, the general purpose GPU model, has been using it since 2010 or so. This kind of dense computational architecture, it's becoming a requirement, and it's got to be balanced with the sort of cost and power consumption limitations. So cloud and HPC then, from that point of view, are sort of moving in very much in the same direction, we think. In the real world, it's a fact that traditional HPC still dominates. Seismic imaging, computational engineering, fluid dynamics, etc. They're resistant to change. They're well-established markets, both in terms of the systems they support, and more specifically the sort of incumbent license regimes and environments. But all these customers are investing also in those more modern HPC workloads and applications which we've talked about, and also I think even more so in the people, the data scientists that are needed than the hardware. And I think HPC users are still working out how they might use those technologies to support, let's call it the business solutions rather than the science applications. And that, of course, brings us nicely onto the sort of academic and commercial gap. And the state of installations at national research labs have different measures of ROI than commercial operations, but there's a lot of cooperation going on with suppliers. So there's a lot of convergence points, and if we think that if only a small percentage of customers will convert to HPC models, that is a significant opportunity for the suppliers to the industry to step up with their offerings. So we think that HPC and cloud, they're still somewhat separate, but they're overlapping, converging, and that the opportunity for enterprise buyers is going to be better as these worlds come together. So at this point, I'm going to hand over to Rob Lalonde from Univa to talk a bit about how how they support that world. And once again, I'll just apologise for the snafu of not being able to move the slides forward at the beginning of my remarks. Rob.
Yeah, thanks, William. That was great. A lot of really interesting data, and certainly we're excited by the shift to the cloud, and we're seeing a lot of activity in that area as well. So certainly what I want to talk about today as well. I think first I'll just do a quick introduction to who is Univa, for those who don't know, and then I'll jump into some of the discussion around cloud. So we hail from the HPC space, obviously, and you heard William talk a lot about some great data around HPC. We have been in this business for almost 10 years now. We acquired the Sun Grid Engine product from Oracle, by Sun, obviously, or Sun by Oracle, I should say, and that formed the sort of the core of our product offering. We're going to talk about some of our new stuff today, but in that core business, we've spent a lot of time investing in the Sun Grid Engine product now, Univa Grid Engine, of course. We have 250 enterprise customers. Our focus is very much on that global 2,000. So as William broke the market up between academic and education versus enterprise, we have our feet pretty solely in that enterprise part of the market where we have 250 customers. We've been focused on commercializing Grid Engine, moving it forward with all kinds of cool capabilities like containers and GPU support over the last few years, and we've also been focused on scale. So you can see we're integrated with thousands of applications. We actually have about 2.7 million compute cores sitting below Grid Engine at various customers now. We have customers going crazy and running 7-8 million jobs a day, doing it on 300,000 cores. We even ran a 1 million core cluster with Amazon just prior to the ISC show in Frankfurt. So scale is a big focus for us, and that's kind of what we've been all about. Our customer base is, as you can see, is very commercial. We have, I think, 11 of the top 12 biopharma companies now in our customer roster, and 70 life sciences customers, actually over 70 in the customer base now. We have about 20 some airlines, A lot of really cool manufacturing companies like BMW and F1 race teams doing things like computational fluid dynamics, crash test simulation, braking analysis, heat dissipation, those kinds of things. You can see over on the left, oil and gas companies doing things like seismic exploration and pipeline analysis and those types of things. So lots of really cool, groundbreaking work happening in the enterprise HPC space for certain. That just gives you a flavor for some of the companies we're working with. As I mentioned earlier, our customer base and our focus has been on Grid Engine for quite some time. Over the last few years, we've seen a shift to more of a cloud strategy, and those are intertwined, as William pointed out. You know, HPC and cloud aren't separate and distinct. Customers are doing HPC in the cloud and still doing it on-prem, and how does that all couple together? So we'll talk about that. But that our separate product line, which I said is integrated still, is the Navops product line, and it's very focused on cloud. We actually spun up the first cloud cluster on Amazon, first HPC cloud cluster on Amazon back in about 2008. And we've been doing work in that area ever since. But we've seen a real shift over the last couple of years to cloud. We did a study 2 years ago, and we saw that there were only a handful of our customers doing anything meaningful in cloud. There were a couple doing dedicated cloud on the smaller side, and then there were a few doing hybrid. But we've seen a dramatic shift over the last year or two. So the latest study we did shows a full just over 60% of our customers are now either in the planning phases or deploying or actually deployed in the cloud. And if you look more granularly at that, 16% of those are deployed in planning, and of those, 70% of those are doing hybrid versus cloud only. Hybrid brings all kinds of interesting challenges because you have to integrate really two disparate architectures. That's what we're going to talk a little more about, how we address that. But you know, our customers want to do both, are doing both, and they're pretty split on, as I said, 70% want to do hybrid, where they're going to extend their on-premise cluster into the cloud, and a good significant chunk, 30%, are going to just do dedicated only down the road. And there's a real mix where customers are doing both as well, so it's hard to break those numbers out sometimes. Just looking further at the data, the top left, you can see the usage by public cloud vendor there. Slightly different data set than Williams, plus ours is just focused on HPC, so the numbers come out slightly different. You can see their focus between the different types of applications, so 35% doing HPC-style applications, but a good chunk doing AI deep learning, and we see that number growing all the time, and then big data applications as well within the overall usage. And then you can see the breakdown by industry. That very much aligns to our customer base because this was our survey as well. But we're seeing a lot of cloud activity in life sciences and education, as you can see on the chart that shows some of the top industries and their cloud focus right now. You can see oil and gas down a little lower, and we'll probably talk about that a little further. But you can imagine organizations that have vast amounts of data find it more difficult to move to the cloud because of that data gravity, because of the cost of moving it, et cetera, and also the cost of bringing those results back down onto premise, the egress cost. So some industries are moving faster than others because of that data gravity, but there's lots of other interesting reasons as well, as you'll see in this chart. So if you look at the first three under resistance, security, price performance, and regulation legal concerns, I've seen over the last few years those issues waning and becoming less significant because I think people are solving those problems. They're getting more comfortable with cloud security. The price performance is becoming much more in line with what HPC users are used to. There's lots of new offerings, big memory offerings from the cloud providers, tons of cores available, and that price performance is improved. And then the regulation and legal concerns. As things change on the legal front, and also as customers just get more comfortable with how they're going to work in the cloud. So as I said, I think those problems are becoming less significant. When you look at things like data gravity, lack of cloud expertise, and data egress, those are ones that I think our customers are still grappling with. Data gravity, I mentioned earlier, is when you have vast amounts of data in the petabyte range. You know, it is difficult to do that migration. You have to figure out a way to shard off what you need to use in the cloud and be efficient in your data movement when you're using the cloud. The cloud expertise one is something organizations are still grappling with as well, as far as getting up to speed with using the cloud. It's, you know, there's a lot of new technologies and new techniques involved. So as I mentioned earlier, our customers are looking to either go hybrid cloud or cloud only. They're both important, and we do address both. So as I mentioned earlier, we've got this new Navops line of products, and Navops Launch is all about allowing customers to extend their existing on-premise cluster or to build new clusters in the cloud. So it allows them to deploy and manage these HPC clusters. It attempts to be entirely seamless. So once the product is up and running, your on-premise cluster can dynamically scale into the cloud and grow and shrink by policy. So you don't need a lot of administrators sitting there pulling levers because all of a sudden someone wants GPU workloads to run, or because a queue on the on-premise cluster got full. These policies, once configured, can automatically and dynamically do that. So the policy engine is a big piece of the launch product, as are the provisioning and the management capabilities. So things like you can bring your own AMI so that you can customize your image. And you know, AMI is obviously an Amazon word, but certainly your image, for whether you're using Google or Azure, you can bring your own. You can set the cluster up your way. You set up your policies, you set up your VPCs, your VPNs, etc., and it's all very seamless. So it is a very complete product from the standpoint of extending your on-premise cluster to the cloud, or allowing you just to build a dedicated cloud cluster. So just a different view of this. You can see the on-premise cluster on the top gray box, the cloud cluster on the bottom gray cloud, obviously, and that can shrink and grow as you need it. So you might start out with nothing. Launch is watching the cluster, watching what Grid Engine's doing, and it will say, gee, your queues are getting a little bit too long here. There's jobs starting to wait. I'm going to start giving you some additional nodes in the cloud. Those end users don't necessarily know where they're submitting the compute to, and that's the beauty of the solution. The scientists sitting, you know, at their workstation doing work can submit their work, and it's going to automatically determine, is this work eligible to go to the cloud? Are there resources on-premise that can do this? Or is this resource requiring specialized, or is this job requiring specialized resources that are only in the cloud, say GPUs, for instance, or maybe a big memory machine that's only available in the cloud? Launch will automatically turn those up, start scaling the cluster up when those jobs trend downward and cloud instances are no longer required. That will automatically start to shut down those cloud nodes, thus saving you money. So a big part of the whole financial model, obviously, is saving money by only using the cloud instances when you need them. Just a couple of quick case studies before we go to the Q&A. Wharton School is a case study we've talked about a fair bit over the last year. Very exciting application. They have, it says, tripled their core count. I've seen them go up to 10 times their core count on some instances when they're bursting. So this is on-prem core count versus cloud core count. So when they have research that far exceeds what they can do on their on-premise cluster, Navops Launch can automatically go out, get them additional instances in the cloud on Amazon, and provide those instances seamlessly to the researchers. If the researcher submits a job that has a, say, I'm just giving an example, a dash GPU tag, for instance, it's somehow tagged with the GPU workload requirement, it's going to automatically, you'll get those instances in the cloud because they don't have GPUs on their local cluster. So this saves companies, you know, money from the standpoint of only bursting when you need to. It also saves a lot of capital investment because you don't need to go out and buy GPUs and keep them on premise all the time. You can rent them as required, and if your usage is intermittent, you're obviously going to save a lot of money because you're just using that on an on-demand basis. So we see GPUs driving a lot of activity in the cloud right now because they're just so expensive from a capital standpoint, and they're not, you know, used all the time necessarily. Another customer here on Azure, this is Mellanox, the InfiniBand people, of course, out of Israel. they have a requirement to run critical simulations, verification loads a few times a year, where they're really going to burst excessively during that time frame because they're coming out with new products, new chips, new designs, etc. And they need to have that large amount of capacity, and then they don't need it at other times in the year. So very, very huge spikes on their utilization. Navops Launch can automatically go get those instances when they need them, spin up a very large cluster, shut it down when it's not required. Again, saving money, leveraging the on-premises design licenses that they would use for their electronic design automation, and really integrating the Grid Engine on-premise cluster with the extended Grid Engine in the cloud cluster. Just a couple of really cool examples. Now I'd like to pass it back to Colleen for the Q&A.
Thanks, William and Rob. It's now time for our Q&A session. As a reminder, simply type in your question in the box below and we will get to as many as we can. The first question is, can you comment on the cost models of on-premise versus cloud, and when it makes sense financially to migrate to a hybrid model?
Sure, I can pick that one up. This is William. So as part of my role at 451 Research, I look after our digital economics unit, which produces a range of pricing indicators to help users understand the relative cost of doing things in different environments and vendors with their pricing strategies. And we've been covering pricing with regard to on-premise, private, public, and managed services now for a number of years. Essentially, when it makes sense to move work into the public cloud when the total cost of the on-demand public cloud offering over a term is less than the manpower that you need to support an on-premise environment, together with the capital and operating expenses to operating it. But but that doesn't really talk about value, because one of the big values of private cloud is being able to retain control. And so depending on the cost, many think this is a premium worth paying, and others are happy to trust a third party. Now, when we take our cloud price index and we price up a basket of cloud goods and services similar to the way a consumer price index prices up a basket of consumer goods and services. So pricing for about 16 different items that you would need to support a cloud application. If you were to choose the provider which had the lowest price for each of those services, you would make a 74% saving in price, in cost, over buying those at the market rate. So this sort of does a couple of things. It shows you that there is a tremendous opportunity or headroom for innovation in order to be able to enable users to consume services in a multi-cloud and a hybrid way. But at the moment, no one in their right mind would even attempt this, because there's simply not the fungibility, the management, or anything that could support that. But what we think is that there is a significant opportunity then for innovation around this multi-cloud and hybrid model. I guess on the other side of that, when we think about data, which Rob's talked a lot about, data has gravity, and initial cost of venue is likely to grow bigger in usage, capacity, and cost, and trying to move that data is an associated cost, not just the bandwidth, but the time and the effort and the risk and so on. So there are things on both sides, both in terms of cost, operations, and technology. But ultimately, we think that it's a model which is going to predominate, because users are going to want to find the most appropriate services and resources in which to run their applications and workloads without having to purchase all the CapEx equipment to do that themselves.
Great, thank you. Next question. Is the automation of use of cloud mostly on the provider side or the user side?
So yeah, I'll take that from a Univa perspective, and we can answer more broadly. But certainly for Navops launch, we're targeting the HPC administrator. So they set up the automation to determine how the cluster is going to burst, what types of instances you're going to use, when it's going to burst, so when it's going to scale down as well. They can work closely with the users to determine what types of instances they might want, memory, when they want to burst, and all those kinds of things. But it is the administrator that sets up the automation, not the end user. The end user can request the resources, but the administrator ultimately determines whether they get them or not. So hopefully that answers the question.
So I mean, from on our side, you know, none of this works without automation. It's automation first, last, and always that underpins the ability to deliver these services now, and you know, it's a front and center requirement for the operation and consumption of services.
Great.
Thank you. Next question is for Rob. For new customers, how much would it cost to license the software to manage APC on-premise and unlimited bursting to the cloud?
Nice. I love when customers show up and ask for unlimited usage. To answer the question generally, we have two pricing models. There's our traditional pricing model, which is very much by core and by instance pricing. Then we also have sort of a new cloud-based model where we charge by core hours. So it really varies by usage either way. But certainly what I would do, rather than getting into specifics on the pricing, is feel free to reach out to me or to Univa, and we can get into more specifics on the dollars and cents and which model, the more traditional or new cloud model, works best for you. But thank you for the question.
Okay, thank you for that, Rob. Okay, next question has a couple parts. How in a particular grid utilization will be active on cloud services, and how the cloud resource managed will be reflected to the grid environment?
Okay, so I think I understand the question. So really you're talking about how the grid is going to be extended to the cloud, I think, and the question's from Rami. So Rami, feel free to reach out to me if I don't address it directly or properly. But Navops Launch extends that cluster. So the resources that are running on the on-premise cluster can get extended by Launch to be reflected in the overall grid. So the grid becomes a single unified grid between the cloud and the on-premise with disparate resources, different resource types, etc. And then Launch and the end user submitters can determine how those workloads are going to get distributed between on-premise and the cloud. Thank you for the question.
Perfect, thank you. All right, next question is, how does the automation in Launch work to expand the cluster to the cloud?
Yeah, so there's two elements to that. It's a great question. So I talked about the policy engine within Launch, that you can set up policies to determine how you're going to scale the cluster, how you're going to scale the cluster up and down. But the part I really didn't get into is how aware Launch is of what's going on the cluster. So it can be bringing information in from Grid Engine, attribute information, and also information from other systems on the cluster, so that it is very aware of what you want to monitor before you make those policy decisions to scale it up and down. So it's integrated into Grid Engine and understands to talk to Grid Engine through the APIs and look at things like queue lengths and types of jobs being submitted. It also can be aware of what's going on the cloud. So has a node been provisioned, but it's not actually up and running yet, for instance, and therefore I can't put work on it. And it can even take information from third-party data sets so that it can leverage that in its decision making. So it's a very sort of broadly capable automation engine. Thank you.
All right, we have time for one more question, so this will be our last question for today. You mentioned that there had been a shift in interest over the last 2 years in HPC cloud migration. What are the drivers for this change?
William, you want to start with that?
Sure. So I think there's a couple of things. So firstly, enterprises are becoming more familiar with a range of, let's call them HPC kind of workloads. I mean, they're all investing in AI, data analytics, big data, and so on. And you know, there's a huge amount of investment in the people, the data scientists, and that's increasingly having a knock-on effect to you know, interest in the HPC environments themselves. I mean, they can see that their cloud providers are adding the same kind of capabilities as these HPC experts already have, and indeed, in you know, some instances, the hyperscalers have actually acquired you know, expertise in HPC in order to accommodate those. Because for the most part, these are folks who are not doing, you know, the sort of seismic imaging and computational engineering and so on. And this is the audience which I think is really the target and the opportunity for the HPC vendors. The other piece is that the technology environment, so the software constructs, you know, in terms of cloud native, containers and microservices and so on, are now becoming sort of first-class citizens as well in HPC environments. So those resources are being matched, if you like, by what's going on in the enterprise, and there's a common sort of developer thread emerging to support them. So and on the service provider and the cloud side, of course, those folks are, you know, driving awareness for the capability for, you know, developing on board HPC processing, even if they don't call it that. These are all specialist. There are lots of specialist chips which are actually, you know, carrying out what are effectively, you know, HPC tasks now. So there's some obvious and some less obvious ways in you know, which that's occurring, and but all of that is driving increased interest.
Nothing to add there, Colleen, from my side. William nailed it.
Okay.
All right, perfect.
Great.
Well, thank you so much, William and Rob. That concludes today's webcast. As a reminder, the on-demand replay will be available on Bright Talk soon. On behalf of Univa and 451 Research, thank you so much for attending, and have a great day.